So today, we are going to talk about those problems from yesterday and make sure that you get those rate problems, because that's really, really important. In fact, I'm going to start with that. So what I hope you remember is that we did a problem where it was a rate plus another rate, and it equaled a total rate. I'm going to give you an example of one super quick, and then I want you to see if you can emulate this. So you should be taking notes like this so that you can tell later how to do this kind of problem. All right, so my dad used to make me pick weeds in the backyard. One of the things I had to do around the house, I had to mow the lawn, and I had to occasionally do like little odd jobs like pick weeds. We had crabgrass in our backyard, and I just hated picking the weeds. So imagine for a moment that I picked 30 weeds in 5 minutes. Notice me using, welcome, I know traffic is terrible out there today. 30 weeds in 5 minutes. Make sure you write the rate down. We can strip the rates off. I don't know if you remember these yesterday, but we can't strip the rates off until we have everything set up, because otherwise you don't know where to put stuff. All right, so let's say that I hire a buddy of mine because I'm like, I got to get this weed job done, and it's driving me crazy. I'll pay you a dime a weed if you will come over and pull weeds with me. So he pulls 10 weeds and he gets $1. I mean, that's a pretty good deal. So he's really motivated, and let's say that he, at that, considering how motivated he is, can pull 50 weeds in 3 minutes. And then we decide to hire out to somebody else as a team and work together to pull weeds. My question would be, how many weeds would we be able to pull together in 5 minutes? Now, I know you're like, dang it, if you'd have just made that be 5 minutes, server, this would be so much easier. Yeah, and then what would be the point? It's supposed to be pre-calc. All right, so what did I say for the ending part again, Taddy? What's the last two numbers I'm supposed to put in here? You don't know how many weeds, you're right, so what do you put there? X. And use a variable that makes sense. W for weeds. Now I know that could look like, a unit, but in a minute I'm going to strip out the units and that W will still be there. W stands for weeds. And then what?
5 minutes.
Yep. So that's the last two pieces of info. You see how everything's got a spot? And you just put everything all together. So this kind of a question isn't that hard. But I'm going to show you how to finish it. What is 30 divided by 5? Yes?
6 over 1.
6. So I can just call it 6. Plus 50 divided by 3, that's not as nice. I'm going to leave it as 50 over 3. And notice I'm just dropping the units. At this point, it's okay to just drop the units. But look at that. Doesn't that kind of look like one of those clear the fractions kind of problems? Do it. Clear the fractions. You should have learned that yesterday. Oh, so you just can go 6 plus 50, and that's 56 over 3?
Yeah.
No.
Well, no. So I said I added 6 plus 50 over 3.
Oh.
So it'd be 68 over 3.
Okay, so you change this to 6 over 1, and then you times by 3. It sounds like you were getting a common denominator. Let me give you some advice. Don't use a common denominator unless you have to, because that's really slow. Watch the fast way.
Should I do a mixed number?
Here's what I would do. Just you tell me if this is faster than what you did. I'm going to times everything by 5 and 3. Now, that may seem crazy at first, but I hope you'll see why. I have two denominators. This is one of the top 20 things. That cancels. That cancels. And now I have 5 times 3 is 15 times 6. 15 times 6. What is it?
30.
Thank you. Plus 5 times 50. 3W. Do you see how multiplying by 3 and 5 right away made this problem so much easier to solve? Clear fractions. That's why it's on the top 20. I can only pick 20 things. You realize we covered there's at least 200 things that we cover since middle school. I can only pick 20. But clearing fractions is one of them. Why? Because kids generally aren't awesome at it. But hopefully you're getting better now. 250 plus the 90 makes 340, I think, isn't it? Divide by 3. What's W? Well, I'm glad I labeled it. Otherwise, I might think it was like, chickens or minutes or... Now I know it's weeds. So whatever 340 divided by 3 is, that's how many weeds we'd pick. All right, let's see if you really got that. I'm going to give you another problem that's similar. Okay, let's say this is picking up shells on the beach. Okay, there are some people that are just really good at that, and there's other people that, aren't. So let's imagine, I saw a lot of old people in Florida who are really good at picking up shells. They've actually got systems for it. They have like things that they can pick them up with, so they don't have to bend all the way over. They have, sometimes for shark's teeth, they have this little scoop that has like a mesh in the bottom of it so that they can scoop a bunch and then shake it and the sand comes off and they can see the shark's teeth in the bottom. And so anyway, let's say Mary, she can pick 18 shark's teeth in 30 minutes. I'm going to give you the rest of the problem, but you have to set it up, okay? One day, Mary teams up with Jack, and together they go out picking, and they get 45 shells in 30 minutes.
Both of them?
To working together, they get 45 shells in 30 minutes. Then, remember this guy's name was Jack. How many shells can Jack pick in 1 minute? Let's make it 2 minutes. That might make it a whole number. Otherwise, it's probably a decimal. All right, next thing I want you to get used to is this next test does allow a calculator. And so you may as well have a calculator out and bring it for the next several days, okay?
Mr. Server, so we're trying to find how many shells Jack picks
Alone
in 2 minutes. Yeah.
in 2 minutes.
Okay.
Yep. Okay, now, I know these are tricky. So I know there's probably some of you that are not sure how to do this. Watch close. Mary plus Jack equals the total. What I told you was the total. So we put the 45 shells in 30 minutes over there. How many of you knew that? Raise your hand if you had that in the right spot. Okay, good. Now this feels weird because you're like saying you know Jack's rate, kind of, but you don't know Jack's rate for shell picking. I'm going to use X because I just don't like S as a variable. It looks too much like a 5. Okay, so this time it's X, and I'm going to know it's shells. But you do put 2 minutes here. Why? Because that way when you solve it, you'll know how many Jack can pick in 2 minutes. Yes? Oh, you got the answer already?
Yeah.
Okay, so tell me first.
27 shells.
Okay, and then tell me what I had to do to start this problem. I mean, first of all, I had to write the equation, but after you've written the equation, what do you do?
Minus 18 from 45.
All right. I'm going to just think I would include one other little fact, which is that you can drop the units and simplify the numbers. So 18 over 30, let's cut that down and say 9 over 15 plus x over 2 equals, what do 45 and 30 both have in them?
5.
How about 15? So 15 would be 3 over 2. See how the numbers got a lot nicer? And then I can clear those fractions. What do I multiply everything by?
15.
Uh-oh, what happened?
9
9 fifteenths. 9 fifteenths. Okay. Oh, so you're just saying I should reduce 9 fifteenths further. Is that what you're saying?
Yeah.
I agree. So let's do that. What's 9 fifteenths reduced to? 3/5. Okay, I like it. Now I got something even easier to multiply by. Do I have to multiply by 2 twice? No. The 1 multiplied by 2 is going to clear both of those. And then a 5. Some people would say multiply by 10. I disagree. I'd say times by 5 and 2. Why? Because it's nicely factored, so you know what's left behind. You don't have to think about what'll happen when I simplify my 10. So now I got 6 plus 5x equals 15, and I couldn't have made it get any easier than that. Now I just subtract 6, divide by 5, boom, done. Okay. Do you get how we set those up? Let's see if you really do. This is the part where on this last one, all it matters is can you set it up right? And you're going to compare with the kid next to you and see if you set it up right. Okay? Yes.
I did it a different way, not the same answer.
That's wonderful. As long as you showed your work, you'll be fine. There's lots of ways to do it.
Okay.
All right, but one of the main things is can you replicate your way? Will it work on the next problem? So try it on this problem. Okay, so on this one, we're going to go with Mary and Lynn are out picking shells. Okay. Together, they find 40 shells in 1 hour. Lynn goes out alone. And Lynn she's got 15 minutes. And she finds 5 shells. There's a trap. The final question is, what's Mary's shell picking rate? And when I ask for her rate, do you guys think it'd be easier to figure out her rate per hour or her rate per minute? What makes more sense to you? I heard 1 minute, I heard 1 hour. Do you guys want to do her rate per minute or her rate per hour? Okay, a lot of people are saying minute. We'll do rate per minute. So find Lynn's rate per minute. You'd have a calculator, so all you're doing is setting it up. You'd be able to solve it later with a calculator. So can you set it up? So this is Mary's rate per min. I'm going to pause for a second. Let me try that. So I hope that Lynn's was pretty easy. It was 15 minute over 5 shells. Oh, yeah, I can reverse that, sure. Do you have to? No, actually, you don't have to. As long as you label it, you can have everything upside down. But I agree. So far, we've been putting time on the bottom. And I'm aware that there's a... Just hold on for some of you smarty pantses that are like, wait. So 5 shells in 15 minutes. Now, that's okay. But then when I put the together part, and I go 40 shells in 1 hour, what happens when I strip off all my units? I get it wrong. 'Cause why?
Because 1 hour, minutes an hour.
Yep. So I got to change this 1 hour to 60 minutes. You need to watch out for that because that's for sure something we play with on the test to make sure you get the same units. Okay, now Mary's rate for 1 hour, I would maybe just use R for rate in 1 hour. Oh, you're right. We didn't say minute per minute. And now, have we got the same units all the way across? Watch for that, because that could really screw you up. And then, if so, then I can drop all the units, and I just have R, which is the same as R over 1, of course, plus 5 over 15. I can definitely simplify that down. Okay. It's been one of those days. This, I think, is the car... Oh, nope. They quit calling me. Yay. Okay. I also had to... I'm going to have to Uber home today because my car... I hit the deer the other day, you know? So anyway, my wife had to go up north to take care of my daughter who just got mono in her last 2 weeks of college. Right before finals. How would you like to get mono where you can't even get out of bed for the last 2 weeks of finals? I don't even know what's going to happen. Really, really sucks. And if it was like in the middle of a normal school year, you might say, well, how about you take the final late or something? But now when you're a senior and you're just about to graduate. So my wife had to go up and take care of her. So it's been a day. All right. So anyway, I'm going to simplify that. And I'm going to say 5 goes in there once over 3. And then equals 40 and 60. Oh, that's going to simplify real nice. 4, 6, 2/3. Look at that. Nice and easy. So I'm going to subtract from one side, and I get R equals 1/3. 1/3 of a what?
Minute. And 1/3 shell.
1/3 of a shell
So it'd be easier to do it in hours.
per minute. Not that you're trying to show that your way would have been better.
Oh, it works. I got the same, yeah.
Okay, so yes, this actually probably would have been a rate that might have been better in hours because then we wouldn't add a fraction. But yes,
On a test, do you want us to like,
on a test you could pick either one of those two rates.
would you want us to tell you like what R means?
Oh, definitely.
Okay.
Yeah, you don't want to just end with a number. You'd want to say what it is, units. So like in this case, I'm going to just finish it here. R equals, subtracting 1/3 from both sides, 1/3 of a what? Of a shell per, and that was minutes. So that obviously means in about 3 minutes she gets a shell. Okay. So I hope you get how to set those up now. We've spent as much time as we can on those. So let's move on to other things. So, get to the next slide. The box problem, except different. Do you guys remember doing the box problem? Do you guys remember we've done it like twice or 3 times and then it came up on the test? And it's still here? Yep, because it gets more complicated. But it's still the box problem. This time, they don't have a piece of paper that is being cut out. There's no like X being cut out of the corners. So let me give you advice on how to conquer these types of problems. Always start with the formula involved, okay? So what they want is a volume problem. So start with the volume formula. Everybody, write down the volume formula near the top of your page. And make sure you have both sides. Some people just put one side of a formula. That really doesn't work well on these. What's the volume formula for a box? Now, I would have said length times width times height. But I look at the problem a little closer, and I really shouldn't say length times width times height. What should I say?
Oh, depth times width.
Depth width height. So volume equals depth times width times height. So write that down to start with. Okay. Now, always start with the full formula. Then stick in what we know. Do we know some of those things? Yes. What do we know? It has a volume of 1,000. Okay, so I'm going to put in 1,000 right here. 1,000 equals. Now it tells us a little bit more. Can anybody see it? I need somebody smart here. Yes?
Width is X.
Yes, the width is X. So let's put in an X right there. That is important. There's more in the problem. Everybody just read the first sentence over again and try to pick up what's the other thing they're telling us. Because I can't just write D times X times H. I got 3 variables. I'll never solve that. Yes?
It has a square base.
So what does that mean?
That its width is the same as its depth.
The width and depth would make up the base, right? And if it's a square, do you get width must equal depth? So we're going to erase D and put in X. Would you have been able to do that? I hope so. Now, question number 1. Before I even look at the question, I would have set that up. And I think you should too. How do we start? the formula, stick in what you know. Okay, now express the height in centimeters as a function of the width, x. They want height as a function of x. They want you to solve for what? H. And what's going to be in the answer? X. Do you understand that? They want you to solve for H, and X is going to be in the answer. Okay, so do it. That's on the top 20 also. Having multiple variables and solving for one of them. Why do I keep on pointing out the top 20? Because if all of these are top 20 things and you got weaknesses all over the place in those, then expect this to be really hard. That's why I was trying to get you to fix those weaknesses. Many of you have. All right, dividing by xx, except I'm going to divide by x squared. Does that make sense to you? And then these will cancel. And now h is allowed. And h of x, it's like h, is 1,000 over x squared. Do you get why this is in the fraction functions chapter? Because that's a fraction function, isn't it? What do you know about the domain of x? As in, what can x be?
Anything greater than 0.
Why can't it be 0?
Because otherwise you wouldn't have any width.
You wouldn't have any width or depth. Yep. So clearly x has to be bigger than 0. Is there any limit to x?
Well, technically, not in the problem, but in the real world. So this is not true.
In the real world, it'd be a little weird to make your box super tall and tiny. So you're right. The real world might have some more constraints. Like your boss might say, you can't make the box look like a straw, like incredibly long and tall. We don't want that. Okay. But for right now, you're right. It doesn't say anything. So x can go from 0 to infinity. That's the domain. You'll have to do the domain. So pay attention. Okay. It says solve this and interpret. Well, basically, it's the height depends on the width you pick. Does that make sense to you? If you're going to have a volume of 1,000, do you get that the height depends on what box width you pick? If you pick a really big width, you have to have a small height. All right. Do you get that the bigger this is, the smaller this is? If x is really big, do you get that the height is really small? If you have a really big width and base of this box, then the height can't be very tall. It's got to have 1,000 total. So the bigger you make the x, the smaller the h. That's got a name, and we're exploring that today later in the hour. There's a name for that. And remember when they divided by x. Well, see, a lot of things in life aren't that way. Like if you spend more time in the gym, your muscles get bigger. You know, more and your muscles get bigger. Usually things are directly proportional. Okay, if it gets colder outside, they sell more ice cream. No, that one's the one to go the other way around. If it gets colder outside, they actually shut down some Dairy Queens, the smaller, more like regional ones, because people don't buy ice cream when it's super cold. Okay, so lower temperature. Well, actually, in this case, lower temperature, lower ice cream sales. Ooh, that one's direct again. But this one, the bigger the width, the smaller the height. That's called inverse. All right. So, I don't want to keep going with this, but I do want you to know that you'd be able to use a calculator to solve this thing. And do you get that if you wanted a certain height, you told me, I want the height to be 10. Wait, I'll write it in blue. Then you could solve that by graphing. You do know that? Do you remember that that's one of the best things you can do is graph both sides and see where they cross. That is a super powerful strategy. In fact, I've given you a list. Number 1, you should look and see if things can factor. This one is not one of those. Can I clear the fractions? Actually, I can clear the fractions if I want to get the x squared alone. That's a good idea. Or I could do that, graph both sides and see where they cross. That's another really powerful one. Where a lot of really smart kids later this unit are going to be sitting there going, I don't know how to solve it. You be the kid who goes, oh yeah, I could graph both sides. See where they cross. Yes?
Would there be a limit to x because it has, because like height can't be 0? Or, oh no, because you can't make 0 on the bottom. Okay.
Answer your own question. All right. Okay, again, I want to not go further with this question right now. I might come back to it later, but there's not unlimited time here. Okay, next up, there's this one. Do you remember doing this one? We did one like it yesterday. Do you remember that I said you could not multiply both sides by x squared plus 1? Man, would it be a lot simpler if you could. But I even looked it up because I know some teachers actually do it that way because it's so much easier. But it says right on the internet, of course, you know, we're the decider of all important information. You can't divide an inequality by a variable. Okay, so unfortunately, we have to get this set equal to 0 by subtracting 1 from both sides. Do you remember this one? So now I've got 3x minus 1 over x squared plus 1 minus 1 is less than or equal to 0. We can absolutely do common denominators. So I'd multiply this x squared plus 1, x squared plus 1, and now I got a common denominator. I'd like you to figure out what that equation is that's less than or equal to 0. And then remember, you could graph it. And you're going to have a graphing calculator on your next test. I'm worried about this right here. I know somebody's going to screw up the algebra in that. So I'll do it out the long way. 3x minus 1 minus x squared minus 1. So that was negative x squared plus 3x minus 2. And then, do you remember you can't really factor that because it's got a negative on the lead term? So remember what we did? You factored out the negative 1 and then it does factor. All right. That is a complete repeat of yesterday. We did that problem yesterday. All right. If we talked about a problem twice, does that mean it's important?
Maybe.
Yeah. All right, so let's just finish this because I see enough people staring at it going, I don't know what to do. We're going to factor out that negative 1, and then you'd have x squared minus 3x plus 2 all over x squared plus 1. And if you can factor it, you should. Henry, you remember how to factor it?
Well, yeah, I factored it into the quantity x minus 2 and the quantity x minus 1.
Nice. And so the two key numbers that I should put on my number line, and why do I know there's a number line? Anytime you got one of those, a less than or equal to, you got a number line. Now, my two key numbers are 2 and 1. Here's 1, here's 2. Empty, empty. Now, let me see here. These things would make it equal 0. Like if I put in a 2, it would become 0 on the top. The bottom wouldn't have a problem with it. The bottom doesn't turn into 0. And then it equals 0. So 2 would work. So I fill this in. And the other one also makes it 0, so that would work. And then I just have to test intervals and see where it ends. Do you remember? Who's got a short-term memory from yesterday? Was it outside or inside? So I'm pretty sure it was outside. I did it twice, though, so I don't feel bad. So I'm going to put in a 3 here. I'm going to test the 3. And I'm going to put the 3 here, and here, and here. And remember that I don't need this to be an exact number. I don't need it to be an exact number. I just need to know this is a negative here, so it's a negative. This 3 minus 2 would be a positive. And this 3 minus 1 would be a positive. All over a positive. And that equals a negative.
So
Are negatives less than 0?
Yeah.
Yep, it worked. And if you tested 0, you'd also find that it worked. There's my final answer. Can you leave it like that? Yep. Because number lines are an appropriate way to leave your answers. Okay. This one. Word problem. This is kind of messy, but it's a garden seat. It's along a wall. That blue thing is a wall. And X is one of the sides. Why are these both Y? Well, look at it. Look at the garden. Do you get how those would have to be the same? It just wouldn't make sense if you're making a rectangular garden. Why would it have to be the same as each other? Otherwise, it wouldn't be a rectangle. You're using the wall of the house. Why? Because that's a natural fence. You don't have to buy any fence for that. Okay, so what did I tell you to start with last time? Last word problem we had. The equation. What's this equation about? Is it about volume this time? No, what's it about? It's about the fencing. And the area. Oh dear, it's got 2 equations. Let's start with the area one. What's area equal to? Would you agree it's length times width? So in this problem, do we know any of those? Look closer. All right, I really didn't give you a chance to read it, so I'm trying to rush here because there's so much to cover, but 100 square feet. As soon as they said square feet, I know it's area. Did you know it's area? And what's our length in this case? Let's call this one the length. And let's call this one the width. So length is X, and the width is Y. So I think you should always start with a formula in both sides of the formula, and then I think you should stick in what you knew. Do you get as soon as you wanted to tell me what X was, I'd instantly be able to solve for Y? Now that I got this formula written out. Okay. What if I wanted to get X alone? I could just divide by Y on both sides. X would be 100 over Y. Or I could go the other way. And I could divide both sides by Y. Is that what I did the first time? Sorry. X. I could divide both sides by X. And then Y equals 100 over X. All right. So, last but not least, I got a perimeter formula. Normally, perimeter is 2 lengths and 2 widths. But look at our scenario. Because we're trying to use that house, do you get our perimeter isn't 2 lengths and 2 widths? Do you get our perimeter would be X plus what? 2Y. That's our fence. The dotted line is the fencing around the garden. So perimeter is X plus 2Y. What are the dimensions of the garden? Oh, I should highlight, not scribble it out. What are the dimensions of the garden which will minimize the amount of fencing she needs to buy? What is the minimum amount of fencing she needs to buy? Round answers to the nearest foot. Okay, well, I would like to clean this up. Would you agree so far I have 100 equals XY? You with me so far?
Yeah.
Do I have another equation?
100 over X equals Y.
Perimeter is X plus 2Y. I mean, we could rearrange this one all day if you want, but do you get I have 3 variables and that makes it very hard to solve? But what happens if you have 3 variables and you want to solve it? You want to maximize the perimeter. Sorry, you don't want to maximize the perimeter. You want to maximize the area. You want the area to get the most area. No, actually, sorry, I read it wrong. You want to minimize, right there, you want to minimize the amount of fence she needs to buy. That makes sense. Nobody wants to pay extra for more fence. So we want this to be small as possible. I got 2 equations. What do you do when you got 2 equations? Yes, Isaac? So is 100 equals xy equal to p equals x plus 2y? You don't want to set them equal to each other. But you could, there's something you got to do.
Graph.
It's a good guess. Graph both and see where they cross, but this is 2 separate equations, and one of them's got p in it. Yes?
Do you use substitution?
Yes. Do you get if we could get this down to just one letter, p, and one other letter? If it was p equals like x plus 4x or something like that, or just 5x, do you get, then we'd have an equation that is 2 variables, and then we could graph it? All right, so I know it's tricky stuff. It's tricky enough that you definitely want to be doing some practice problems with this. I'm going to just say, to finish this one, this is your homework. There's only like 3 homework problems, okay, and this is one of them. And I just got you a long ways down the road to it. But you have to substitute. Do you get I could solve this for y, and then I could stick it in somewhere? Or I could solve this one for x, and then I could stick it in somewhere down here? And then I just have one equation that has p and x in it, or p and y in it. And then I could graph it. Now there's an answer key, and there's you and some time and some work, and that's what's left. And I give you a ton of time of help here because I knew this would be a really rough question, and this is a very small number of homework problems. Okay, so this is the part where you need to piece this together. Struggle with it. You know, when problems are super easy, you're not going to get paid very well if all you do is solve easy problems. It's really true. Anybody can do that. So someday you may want a job where you have to solve hard problems. Takes, like, they're not going to just get solved overnight. So this is your hard problem unit. You don't have many. I think your next test has 4 questions on it. And we've already gone over several of them, but they're not easy. So just be prepared to like dig in. These are harder. That's why there's going to be less of them. And if you're the type of kid who just gives up when the going gets tough, then expect this is going to be a bad one. Because if you give up after a minute of looking at it and going, I'm stuck, that's not going to help on the test. All right. And the last thing I'm going to mention is that this is going to be a partner test. And the first thing that you're going to do when you sit down with your partners is you're going to show them your homework from this unit. Why? To show how hard you were trying to get ready for this test. Would you forgive the kid who's having a hard time helping but did every homework problem, like really tried? I think most people would say they were trying. Last thought, your partners are going to be people who have the same grade as you. The research has shown that it's actually the most fair way to group and gets the best overall results to group people at the same grade. So I know some of you have been really top students. You're all in the honors class. Okay, so some of you have been that top student, and you're like, oh my gosh, this kid knows nothing, and you end up doing the whole test for them. That won't happen because the very top kids are going to be stuck with the very top kids. If you're kind of in the middle of the class, you're going to get somebody in the middle of the class. And then there's usually this rush right at the end where people are like, oh my gosh, I want to turn in like some late homework here because my grade doesn't look very good and I don't want to have a bad partner. Well, then maybe you should make your grade as good as possible before our next test. All right? So do your homework tonight because you're going to be showing your homework to the people next to you when you're taking this test with them. And all they can ask is that you tried it. But if your homework is just there blank or you can tell they're just farting around drawing pictures on it, you'll know what kind of a partner you got. Okay? So do your homework, especially this unit. There's not too many problems here. Wait, I missed a page that was important. I encourage you to do all of them and check them with the answer key. For good Pete's sakes, we give you the answer key. Obviously, it's not a matter of like, I didn't know what to do. There's an answer key. It's just, are you willing to practice or not? Okay, so partner test coming. Current plan is we have 1 day of review tomorrow and the partner test the next day. But I know that seems cuckoo. But it's also possible that it could move, but that's the current plan. Yes?
Are you gonna put something out bad enough for when the tennis ball back very soon?
Eventually, yes. That's a low priority for me right now. Yes?
Videos on Schoology, right?
The videos are always on Schoology. This one isn't there yet because I haven't even recorded one. I mean, I'm recording it right now, so, you know.
I just have this.
All right, and that's all I have for you for today.